Greetings to everyone who's watching. My name is Otembele Tanebe. I stand before you as a member of 5 Rangers who are doing their second year in analytical chemistry at University of Johannesburg. Today we'll be discussing a research that was done by analytical chemists about the removal of sulphates using electrocoagulation sludge as an adsorbent.
Greetings everyone, my name is Saragana Jamasi and I'll be introducing the concept of electrocoagulation.
Good day everyone, my name is Sifiso Dlamini and I'll be doing the material and method.
Good day everyone, my name is Basam Daub and I will be doing the results.
Hello everyone, my name is Aviro Chobonga and I will be doing the conclusion.
You may wonder why we chose this topic. We chose this topic because it is a crisis that we are currently dealing with as it affects our health and our environment. And what is this problem? The studies have shown that high concentrations of sulfates is very harmful and damages the infrastructure of wastewater treatment plants, such as sewer lines, pipelines, and storage tanks, and that will lead to the production of hydrogen sulfate. The hydrogen sulfate production causes corrosion and secondary contaminants, as that will result to a reduced lifespan of wastewater treatment plants. Hence, the analytical chemists produced the application of electrocoagulation sludge as an adsorbent to remove sulfates from the industrial effluents before they are sent back to the environment.
Electrocoagulation is an electrochemical process used for wastewater treatment. It is used to purify and remove contaminants or pollutants. It can be used to remove heavy ions such as sulfate. It is a very cost-effective solution as the corrugated iron sludge used is readily available, eco-friendly, and reusable.
Material and method. So the material that will be used in this experiment is the wastewater from the battery plant, sodium sulfate, hydrochloric acid, sodium hydroxide, and all solutions will be washed using ultra pure water. In this experiment, we'll use corrugated iron found from a local scrapyard where it will be washed, polished, straightened, and made into strips where the iron sheets will then be immersed in a beaker containing the sulfate solution. A stirrer plate will then be used to make the solution homogeneous. The iron will then be set up in a monopolar alignment by connecting it to an electrode that contains an anode and a cathode. The voltage, which has to be between 3 to 15 volts, will then be applied from 20 to 120 minutes while the water is being stirred with a magnetic stir. The electrodes will then be rubbed softly with sandpaper to remove scaling and resin surfaces while washed with ultra pure water. Electrocoagulation will continue to take place for 120 minutes and the solution will be left to cool. The precipitates will then be filtered off and the filtrate formed will then be analyzed for the sulfate concentration. The pH will be maintained using hydrochloric acid and sodium hydroxide. This table shows the composition of wastewater before and after the electrocoagulation process has taken place. So the removal by electrocoagulation was 99% and the other removal by electrocoagulation was 95%.
The removal of sulfate and other pollutants from real industrial wastewater. Most industrial wastewater typically contains more than one contaminant. In this study, a wastewater sample was collected and analyzed. Arsenic, chromium, and lead were found with different concentrations. The adsorbent removed more than 98.7% of the sulfate ion in the presence of arsenic, chromium, and lead, which were also eliminated alongside the sulfate ion. This could be due to the adsorbent's high surface area.
In the final analysis, this study demonstrates the effective use of electrocoagulation sludge in removing sulfate ions from industrial effluents and synthetic samples. About 95% of sulfates at low pH were successfully removed using easy sludge. The Lamier equation was better fitting than the phenolic isotherm. Chemisorption was proved as the dominant removal of sulfate ions. The sludge can be recycled up to 3 times to eliminate more than 60% of the sulfates.
We would like to acknowledge our analytical chemistry lecturer, Ms. Mabuba, for providing the study that was used to create this presentation.